I can't repeat important things often enough. And this is a very simple thing. In terms of questioning whether or not there is a conspiracy against us to socially engineer us into a condition in which we do not pursue free energy, there is evidence that this is the case. And the evidence is this: how we teach basic electricity for students of electrical engineering at the very beginning, the very first course they take. I never managed to get through it because I knew there was something wrong with Ohm's law, but I didn't know there was more than that going on. But that's all I could, because that's all that was presented to me, that's all I could find fault with. And sorry. What I learned since then, starting about 2 summers ago, is that Ohm's law is not the whole story of basic electricity. You also have to take into consideration electrical reactance formulae, capacitive reactance and inductive reactance and reactive impedance, and then you have a whole picture. But because of what I know to be true about current, so that gave me a different perspective, and also all the simulation work that I've done. So then I realized 2 summers ago that current is a mathematical fiction, a form of shorthand notation to make Ohm's law look simpler than it is. So they've been boiling everything down, leaving things out, reconfiguring things to make things look so simple as if they're talking to children, because that's what they want us to be. Dutiful devotees of their social programming. This is the conspiracy that I have in evidence before me that I'm trying to share with you. So, current is a symbol. If you have a complicated mathematical equation, very oftentimes, if you want to ignore certain areas and just focus on other areas, you'll take out the I want to say expensive areas, the complicated areas, expensive in terms of dwelling on them because they're not what you want to focus on, or in this case, due to social programming, you don't want the public to focus on them. So you replace them with a single symbol, and that's what's happened with the symbol that we call for current, capital I. It has nothing to do with Ohm's law from a standpoint of fundamental functionality. It has nothing to do with it. It's totally a man-made contrivance to oversimplify, and it goes along with our so-called common sense. In other words, it favors an illusion that there's something flowing between point A and point B to neutralize the difference in voltage between those 2 points. It's an illusion, and the illusion is exacerbated or repeated or reinforced by a phenomenon that is best described by Eric Lethwaite, if I'm saying his name correctly, professor, now deceased, in England, an English college. I forget the name of the college. And there's a YouTube video, and he does called Magnetic Currents, I believe it's called. And he does a superb job of alleviating our illusion or delusion in thinking that a current is traveling. Now, once that gets translated by way of thermodynamic conversion into a different form of energy, then we have a movement going on between the 2 points of voltage difference. But within the magnetic field itself, there is no movement at all. Within the wire, the so-called wire carrying a current, conducting current, there is no movement whatsoever between point A and point B. Because if you imagine you're holding a stick at one end and your friend is holding it at the other, when you shove that stick, he feels the movement immediately because the whole stick moves, not anything moving through the stick. So this is not water through a pipe. The analogy breaks down. It doesn't work. What it is a stick. That's the only way anything travels anywhere. Whether it's a conductive medium or a resistive medium, a dielectric medium, it becomes more obvious that that is the case. In a conductive medium, it looks more like a rope with some slack in it, and you give it a flick up and down to create the movement of a ripple moving across, thus at 90 degrees of angular displacement from your up and down movement. But it's an illusion, it's a mirage, it's a pattern, because our brains are pattern-oriented. We're always looking for patterns. If you were a newborn infant, you wouldn't see any patterns. You'd see globs of color, and it wouldn't mean anything to you. But because we have developed this intellect of ours, it creates a non-receptivity to new ideas. As children, we were very open and receptive to new ideas, but once we've been trained as electrical engineers, we're not open to new ideas. We've been trained a certain way to see things, to reinforce how we see things. And so we're given the water analogy to make sure that we think there's something flowing between the 2 points of voltage difference when there's nothing flowing at all. It's a pattern that is flowing, and that pattern is nothing more than information. And the best analogy is even better than the stick is only really good for dielectrical medium of how you transmit through. You don't. It's simply you charge it, and the charge is recognized on the opposite side practically instantaneously. No, the correct analogy for conductive movement is, of course, the rope with slack in it, and you flick it at 90 degrees up and down to create the ripple moving across. But there is an analogous situation in which it's called the Mexican wave, or simply the wave. You're in the football stadium, or soccer if you prefer, and you're bored with the game is going pretty slow, or it's halftime, and somebody in the crowd decides to start the wave, and they stand up and raise their arms, and they sit down and lower their arms. And on the opposite side of the stadium, it looks like a wave is traveling around the stadium. But when it reaches you, you know better. You look out the corner of your eye, you know immediately the instant moment when you're supposed to stand up and how quickly you stand up and sit down. And that regulates the speed of this thing as well as the direction. Yet it's simply a pattern that's moving, because the movement is up and down. It's not moving sideways or circularly. So this is a perfect analogy, but another analogy, and I have to give you more analogies because I should not give you a paucity, because the more analogies you have, the more you'll be able to see this from different perspectives. So another analogy is the cam drive in our internal combustion engines. In order to change reciprocating motion of the pistons in our engine into rotary motion. And of course that's internal, and most people don't see it. So maybe a better analogy is the cam drive on the exterior of old-style locomotives, the steam engine variety from 100 years ago. You had to have a little starter arm to make sure the wheel always turned in the same direction each time. And the starter arm was a separate extra length of rod that was connected to the main cam drive rod that was connected to the wheels. So that mechanism, the cam drive mechanism, converted one form of energy into another form. It converted reciprocating motion into circular motion. But it's a conversion that takes place. And the reciprocating motion is the flick we give to the rope. And that flick moves down the rope, the slack rope. And because it moves, we call that moving forward, but it's the flick that's moving forward, not energy. In other words, it's people standing up and sitting down in sequence, much like a conductor in an orchestra decides to do syncopation on the two sides of the orchestra. So he tells the violinists on his left to make a musical statement, and then he points to his right to the cellists to respond and maybe mirror or contrast what the violinists were saying, but do it slightly differently. And because it's a different instrument, it also enhances this talkback, this conversation to the two sides of the orchestra. Well, he's conducting them. He's telling them what to do in a reciprocating manner, and it's flipping back and forth between your left ear and your right ear, and your left vision and your right vision. That's reciprocating motion. That's a pattern. But that's an obviously reciprocating motion which has not been converted into circular motion to delude us into thinking that a helical shape of current is running down the line. It's not. It's not helical at all. I even have it downloaded on my website, vinyasi.info/N as in Nancy, E as in Edward. on the power factor, the second power factor circuit of Paul Falstad's group of circuits. I have my circuits separate from his, and in his allotment or group of circuits, he has something called power factor. He has two versions. The second version has, I put in there an information file that you can click on a button in the upper right-hand corner, and it's the picture of a wave, a sinusoidal wave, but it's done in 3 dimensions so that it looks like a helical wave. And so this is another fallacy that we're taught, that this 90-degree displacement between magnetism, the magnetic field, and the dielectric field that we normally call the electric field or electrostatics, the magnetic field and dielectric field, they still have one thing in common, and that is their traversal across the length of the wire, so that their 90-degree displacement is at right angles to that traveling direction down the length of the wire. So their 90-degree displacement is across the diameter of the if you did a cross-section slice through the wire at right angles to its length, that is where the 90 degrees is at, the displacement. Well, but magnetism, or I should say current, which spawns magnetism, is a fiction. So it's possible when you do these things to come up with your own variety of what is the 90-degree displacement, when in fact the 90-degree displacement is between the length of the wire and the diameter of the wire. It's the most displaced you could possibly be, and that is where the displacement occurs. And the displacement is not current. It's between two sets of organizing the voltages involved in Ohm's law, because the correct version of Ohm's law is not it's not voltage times current. So all you have to do is what is current in terms of Ohm's law? It's voltage divided by resistance. So you plug that in place of the current, and now you have voltage squared divided by resistance, but that's not the whole story. They are not the same voltages. If you really want to get into the nitty-gritty, they are 2 separate types of voltages. One is applied, and the other is reactive. And the resistance is not really resistive, it's impedance, because now we're getting into electrical reactance being considered simultaneously with Ohm's law in order to understand Ohm's law and define it in a robust manner, with all of its particulars intact and not excluded from this picture of reality of Ohm's law. So Ohm's law is still fundamental to electrical science, but it has to be understood in terms of electrical reactance formulae, whose most primary fundamental feature is time, which is not included in Ohm's law at all. And yet it's included on my electric bill, kilowatt hours. So it is pretty important, more important than capacitance and inductance and phase relation and frequency. The 60 cycles that of 240 volts delivered to my residential customer status that I possess. Time is more important. How long? Duration was your expenditure of energy, because it matters a lot. Now, as a minor footnote, not related to what I'm discussing, Jim Murray did an experiment with a friend of his in which they managed to blow up a substation because they weren't planning on it. They were clueless. They wanted to perform the experiment because they didn't know what was going to happen. They wanted to see what would happen, if anything. Maybe nothing was going to happen. But they isolated the substation from the grid, yet it was still being supplied with energy from the grid, so that anything that happened to the substation would not ricochet back to the grid. And what they did was they doubled the frequency within that substation. They turned 60 cycles into 120 per second. And you know what happened? The power level of that substation automatically, all by itself, with no change of input power at all, increased its own power level by a factor of 4. The squaring of the doubling of the frequency. They got the square of the doubling in terms of power gain just by increasing the frequency. And you know what that tells me? That's reactive voltage taking place, building up in the system. And because it was isolated, it was probably what they did was they shorted it to itself to make it isolated yet still connected. So it was connected by a single wire, probably a single terminal. instead of both terminals. So they probably just disconnected one of the two terminals. The input, the output, they chose one of them, and probably looped it back to itself so that it would still have a current path, and it was probably still grounded to give itself a place to drain to. And that's probably why its power level quadrupled, because it was allowed to manifest current. Still allowed to manifest current, yet it was only connected to, I'm guessing, only connected to the grid by way of one terminal, so that the voltage would still be coming in and the frequency would still be coming in. But they somehow, by means I cannot guess at, managed to double the frequency, yet get a quadrupling of the power. So this is why Ohm's law is not the whole story. And it's erroneous to teach it as if everything is fundamentally nothing more than a flashlight circuit. You know, I did this experiment 2 summers ago. This is when I learned about this. I was writing a provisional patent, and I felt, well, the United States Patent Office is a pretty hard nut to crack. They're so conservative, anal about their conservative outlook, that they will not consider anything that purports to be over unity. Yet that's what I was trying to promote. Now, this was a provisional patent, so it was never dissected by one of their patent attorneys over there, just as well. But nonetheless, I still felt a certain pride and dignity that I had to uphold and do the best job possible. So how was I going to go about trying to convince the patent office when nobody else can? Well, probably nobody can, because it's a policy, irregardless of whether or not they can be convinced. That could be. But regardless, I thought it necessary to improve the situation. So what can I do about that? So I took the position of Euclid. When I was a child, I remember reading certain things from ancient Greek philosophy and sciences that really made a big impression on me. And one of those things was Euclid's axioms, that are built up from a very stable foundation, from a very simple premise that everybody can accept. And then he goes from there, each one building on the previous or ones selected that he selects to form the foundation for his next axiom. And he does it in such a nice, logical manner that I thought, this is good. I got to do it this way. So I started with a simulation of a flashlight circuit involving nothing more than a voltage source, a battery, and a resistor representing the incandescent light bulb. So this was, I'm old school, I'm not into the LEDs when I think about flashlight circuits. I think about incandescent light bulbs like Edison. And it was basically a linear arrangement. It was I had it diagrammatically arranged to look like an open line, an open transmission line. Yet the two ends were closed and sealed on each other and linked to ground because they were both grounded. So effectively, they're both shorted to each other. So I created a closed loop connected to earth ground, because microcap, by default, you can tell it not to worry about whether or not you have a ground. But by default, if you don't change that default condition, it always requires that you have at least one DC path to ground. So I had 2 grounds on either side. So I had a plethora of grounds. And then I put solder joints represented by little resistances of 100 microohms of resistance in between my components and in between the components and ground on either side. So I had, what would that be? That would be 3 solder joints and 1 major size resistor representing the light bulb, and then the voltage source being represented by a battery. And so then I did what Jim Murray, I really like Jim Murray, don't I? I wanted to do what Jim Murray promoted in one of his presentations, and he wrote a book on it, The Meaning of Overunity, in which you do what he calls a segregated analysis. You analyze every single aspect of the circuit. And so since the simulator only gives me so much data, I said, okay, I'll use all its data. I will look at every single component, the data of that component, and create a table of summations of wattages. So first I have to figure out the wattage of each component, and I have to sign it with a polarization. is it positive watts or negative watts? Well, the battery was negative watts, and the incandescent light bulb resistor element was positive watts because it was consuming the energy, the negative watts being produced by the battery. And it all evened out. The wattage, the negative wattage put out by the battery was exactly equal to the positive wattage of the incandescent light bulb resistance. And so it all came out to zero. And this supports the Kirchhoff law of voltage drop, what effectively we call a voltage drop, but the Kirchhoff law of voltage. And it also was supporting the Kirchhoff law of current. Because, let's see if I get this straight, the Kirchhoff law for voltage supports our idiotic idea of conservation of energy, while the Kirchhoff law for current supports conservation or consistency. I forget the choice of word for charge. Well, this only works for a flashlight circuit. Once I started bringing in a neon bulb spark gap macro, that has negative. The macro just means a sub-circuit. It's a circuit that emulates the behavior, in this case, of a neon bulb spark gap, a neon bulb gas discharge tube. And among the various components in that macro, there are inductors, there's capacitors, there's digital logic, there's also a negative resistor. Now, how can you get away from the possibility, the potentiality, not the probability, let alone the guarantee that you'll get over unity? But it certainly is possible because you've got a negative resistor in the macro of the neon bulb. And what if you should engineer a circuit to take advantage of that negative resistance of that neon bulb such that you now exhibit a circuit that may not be over unity. It may still damp out and go to zero in a hyperbolic manner. The curvature of your readings, your readout, your virtual oscilloscope readouts, they may still tend to zero, and that's what I was getting. But initially, they exhibit a feature and a format in which certain elements of your circuit are negative watts and certain elements are positive watts. And I at some point in my development, my Euclidean style development of axiomatic logic style of logic, I managed to weed out the power source. Now, see, I was planning on this because I'm accustomed to using pre-charged capacitors as my source of voltage in my circuits more often than not, because it's the easiest way to know that it's over unity. Because a pre-charge is going to get spent like instantaneously, quickly dissipate, and if you still get more power than you put in, then it has to be over unity. And that's the way I challenge myself on how to train myself to be able to come up with over unity. One of the ways, but it's one key feature that I've used a lot and very often to train my brain on how to create the kind of circuit that I want, the outcome that I want, namely over unity. So I had these examples or experiments in my protestation to the United States Patent Office predilection towards being against, over unity circuits or over unity devices. So I had in my essay, it was very long, I had 100 pages of text and 100 figures, or 1 page per figure, or 1 figure per page. So I had a 200-page provisional patent. It was pretty lengthy. So I built my argument up starting from a flashlight circuit with a voltage, with a battery as its power source, until I got to the point that I had a neon bulb in there and a pre-charged capacitor, and still this linear arrangement, this simple loop with 2 grounds on either side. And yet, even though, actually the last point of development, it did not damp out. It actually oscillated at a consistent manner, I believe, as I recall. I mean, you can look it up on my website, vinyasi.info/Mohs law, all one word, no underscore or hyphen between them, MHOSLAW. and this is in honor of Lord Kelvin, who came up with the expression of the MO, the MHO, turning ohm backwards, spelling, to represent conductivity. So I thought I was producing superconductivity at room temperature by having an over-unity circuit, because the current is going in reverse, giving a magnification of voltage difference between two different points that are different in voltage, rather than an equalization, and thus rather than a diminishment of power, because the power is based on the voltage difference. If there's no voltage difference, there's zero power. Of course, you can also have zero power if you do have a voltage difference, but your current is out of phase with your voltage by 180 degrees. But be that as it may, so I got the circuit development to the point that it was not adding up. The negative watts that I had in one column of certain components versus the positive watts in another column, when I sub-tallied the two columns and then cross-referenced them, did a total of those two subtotals, sometimes in the beginning I came out to a loss. It was small, but it was there. And then at other times I came out to a gain. And so this no longer supports the Kirchhoff laws of voltage and current, and thus no longer supports conservation of energy. Now you can say that, well, there was round-off error, and yet that is true only for 32-bit computers, 32-bit style registers in your CPU of your computer, or less. It is not true for 64-bit. 64-bit is incapable of round-off error. It cannot give you round-off error. It's only with 64-bit computers that we actually have the possibility of weeding out any false positive of a simulated over-unity circuit. It's the only opportunity we have, because up until then, you can get a bunch of false positives and not know that you're getting them. But with 64-bit, it's impossible to get round-off error. It is no longer possible to get round-off error. Have I repeated it enough times? That used to be a problem, but it is no longer a problem. Yet we don't know that, because we keep going with this momentum forward of repeating the same nonsense over and over again, even though our technology has superseded that problem. It has overcome it. We no longer have that problem. Okay? Boy, it's easy for me to get angry, but people you gotta wake up. This is called progress, technological progress, to support the scientific data for over-unity. We now have the means to simulate over-unity. All right? So, when we get a difference, when I got that difference between the positive watt column that I subtotaled, and the negative watt column that I subtotaled, Kirchhoff laws are no longer essential for a fundamental understanding of basic electricity, because they've been turned upside down. They're no longer valid, even though the simulator is using them to figure out that the two columns are not equal. So they are contradicting their own validity of significance. They are simply a means to an end. Yeah, that's what you do when you want to figure out what's going on in the circuit, but that doesn't mean they're fundamental laws, because they've contradicted themselves, because they've been shanghaied, shall we say. Oh, that's a terrible ethnic slur against Asian culture. Okay. They've been superseded, there we go, correct word. They've been superseded by electrical reactance formulae of capacitive reactance, inductive reactance, and reactive impedance. Those three formulae supersede Kirchhoff laws in terms of a fundamental understanding of basic electricity. And it is not Kirchhoff laws, then, that should be associated with Ohm's law when teaching basic electricity. That's just for the technician to do the computations that he doesn't want the simulator to do it, so he'll do it himself to double check. Fine, go ahead, do it yourself. But it's not for the purpose of fundamental understanding. Kirchhoff laws are a waste of time. They give us the wrong reality. The reality of a flashlight circuit that you're teaching to a school child. This is not the way electricity works. If you want to be an electrical engineering student, you have to teach the electrical reactance formula at the same time, on the heels immediately after teaching the student Ohm's law. That's the only way to understand basic electricity, is to include time as a potentiality, capacitance as another potentiality, voltage as a, inductance as another potentiality, phase relation, and frequency. If you can't deal with all of those factors, you don't understand basic electricity, and you're talking out your butthole when you talk about conservation of energy, because you're bringing in something that's not related. Bringing in Kirchhoff laws is not related to a fundamental understanding, and over unity is promoted based on an erroneous fundamental understanding of basic electricity. It's an erroneous outlook. And I don't need to go back to school to get retrained and programmed just so I can yell at the teacher that he's teaching it wrong. I'm not going to do that. Why should I go to all that trouble? That's a lot of trouble. At my age, you do it. You're young, you do it. You bawl out the teacher and tell him he's wrong, and play back this recording and tell him how wrong he is. I don't have the energy or the time or the patience to bother. I'm too old for that, okay? I'm in retirement age, okay? So I'm not about to do that. You do it if you want to, if you're so inclined. You do what do they call it, when you audit a class just to sit in and bawl out the teacher. You do it. I don't want to do that. I'm tired of confronting people face to face. I've done that my whole lifetime. So I'm not about to do it anymore. If I want to confront, I'll do it online so that I can walk away, turn off the computer, and take a break, watch a movie or take a nap, because I'm tired of the stress of confrontation face to face anymore. You do that if you're so inclined. Okay, I still like to confront people, but just not face to face, because that's a little too much stress for me to handle at this point. But it is wrong the way we're teaching basic, fundamental electrical theory in basic electricity classes, because we're promoting this ideology of Kirchhoff laws in conjunction with Ohm's law as if that's the last word on the subject, and it's not. It's only useful for a technician to work out the parameters of the dynamics of the circuit and try to, on paper or in his brain, try to mentally conjure what's going on and wrap his mind around it. That's all it's good for. It's not good for a fundamental understanding to teach and to understand how electricity behaves. You have to ignore Kirchhoff's laws momentarily, keep Ohm's law there, sort of, but now add in electrical reactance formulae. And they become even more important than Ohm's law. They supersede the significance of Ohm's law. Even though Ohm's law you can never forget. It's always there in front of your face. Yet, we have an erroneous version of Ohm's law, all because of Kirchhoff's laws being promoted instead of the electrical reactance formulae, which are never called laws. They should be, but we don't call them. See, so we've de-emphasized their significance by not calling them a law. Not, oh well, who came up with them? Let's name them after him. Gee, who knows? It's easy. I never see it in the articles about them, who came up with them, so that we can name them after them and call them laws. They're just called formulae, as if they just appeared on the scene all by themselves, brought themselves into being. They birthed themselves into existence. Come on. Is that our attitude about science, that we don't need to give credit where credit is due? We just created it out of thin air? Come on. It has to come from somewhere. Somebody must have discovered it. There must be some history to electrical reactance formulae and where they came from. Yet we never bothered to emphasize and give credit where credit is due. And that means that we are lacking in good karma. We are lacking grace. When you teach something, you have to do it in the name of your teacher. Where did you get this information from? If you don't, then you don't get to entertain or possess the grace of your teacher. Now you're riding on your own grace, which is pretty limited. But if each teacher rides on the grace of his teacher or her teacher, by giving credit where credit is due, now you've got the grace of the lineage of teachers at your disposal. And that's a huge momentum of force behind your backside, propelling you forward. And this is what science has turned a blind eye to, because we no longer apprentice ourselves to a teacher. We go to school and get brainwashed. And there's no lineage anymore of teachers to give homage to. You know, we call it homage. On the other side of the globe in India, they call it a puja. All the same, it's homage. You give credit where credit is due. You pay obeisance and devotion to your master, your teacher. And we don't do that. We treat science as if there's nobody involved. It's just facts. And then we go and manipulate the facts because no one is taking responsibility for that manipulation, because no one's giving credit. Where did that manipulation come from? Oh, it's a perfect condition for social engineering, is to ignore our predecessors and not give credit to them that is due them. Because now we get to manipulate the field of knowledge and call it, oh, well, this is the knowledge. This is it. So you don't need to give credit where credit is due. Everything is objective now. There's no subjectivity involved. No, there better be, because somebody should take responsibility for the crap that we have before our faces, in which everybody is an idiot because they're programmed to be an idiot. Not because they are idiotic, but because if they want to get paid at the end of the week, they'd better follow the party line. So you think you're somehow different, living in a free country, in the free world, and you're not living under a communist regime of Mao Zedong or Stalin or Lenin? What are you, nuts? You are. You just can't pinpoint where it's coming from. And that was done by design. It's not a mistake or an oversight that you can't find the orchestrators of this symphonic piece called social engineering. You won't be able to find them, because they made certain there is no lineage of masters to give credit where credit is due, so that no one can point a finger at them as the ultimate source of this social engineering. We just think, oh, it's peer pressure, it's common sense, so everybody talks about it, it must be true, because everybody's saying the same thing. Well, they're going through the same schools. The school that I avoided because there was something in my heart telling me there was something wrong with Ohm's law. There was nothing wrong with, well, it is and it isn't. It's simply the consequence. The way Ohm's law is being taught is erroneous, because current is a mathematical shorthand notational fiction, man-made, but it's there because we are promoting Kirchhoff laws instead of promoting electrical reactance formulae to go in conjunction with the teaching of Ohm's law. So that's the way I see things, and why we get away with promoting, conservation of energy, because it's Kirchhoff laws that we call a law. And we give credit to Kirchhoff instead of using electrical reactance formulae to, oops, now the output doesn't equal the input. Gee, I mean, just to give you a pointer, a little heads up, why I think electrical reactance is so important. When I first started training myself on simulators, I picked the right one. I picked Paul Falstad's electronic simulator. You can go to falstad.com and go to his subsection having to do with his circuit simulator, and then he's got the source code on GitHub. And so I picked a simulator in which there was source code available, because I knew I would have to look at that source code on occasion, even though I'm not a programmer. So but I wing it as best I can, because I know how to do JavaScript, I know how to do Perl, but Java I don't know, and all these other languages, and it's over my head, but not entirely over my head. So, because I'm familiar with the programming as it is, so the concept of programming. So I picked a simulator in which the source code was available so that I maybe could make modifications if I needed to, but most importantly to read the source code to understand why certain things work the way they do in an electrical circuit. And this is where the clincher comes for this little recording and discussion. And that is that I began to become curious. I'm plugging in my phone here so it doesn't die on me. I began to be curious about the behavior and why do inductors and capacitors behave the way they do. Why is that? And so I looked up the source code for Paul Falstad's inductors and capacitors. And lo and behold, what do you think I saw in there? Capacitive and inductive reactance formulae. One each. You know, the capacitive reactance formula was in the model for a capacitor, and the inductive reactance formula was in the model for inductors and for transformers. And I was just blown away, because I immediately recognized what I was looking at, and I thought, wow, gee, it must be significant. Because without that in there, his model for a capacitor and his model for an inductor would not have been possible. It needs it. It has to have it. And any piece of wire, you don't even have to have a coil of wire, just a piece of wire connecting two components in your circuit is already exhibiting both inductive reactance and capacitive reactance already in a minuscule way, which the teachers like to think, well, we can ignore it because in a flashlight circuit we don't have any coils, we don't have any capacitors, so we can just ignore that and just teach Ohm's law and leave it at that. But every piece of wire has inductance across its length, not just conductance, but it has inductance. And at right angles to that, across its diameter, when in direction, the plane of its diameter, when you go between its boundary condition at its insulator with its environment, now you've got capacitive reactance because you've got a dielectric surrounding it, serving as an insulator. And that's the correct angle of displacement. And that is due to the fact that voltage squared divided by resistance, that voltage squared represents the area of your cross-section of your wire at right angles to its length. That's the two voltages, but the length of the wire is one voltage. It's your voltage difference that you apply to create a voltage difference between the two terminals along the length of that wire, at the either end of that wire. But the reactance of that wire to the application of that voltage now has to include one more voltage, and so now you've got two voltages spread across its diameter. You've got its initial voltage of applied voltage, but now you've got its reactive voltage as well, creating that area of diameter, that circular area cross-section through your slice of wire at right angles to its length. That is the correct definition of your two fields, because your current is moving up and down. You're flicking the rope up and down at right angles to the length of the rope. So naturally, that's going to be your cross-section. And that's where voltage, reactive voltage divided by impedance is now replacing that symbol called current. But we have to combine it with applied voltage in order to do that cross-section and give us that current. In other words, we have to give ourselves watts at the same time. We have to consider power, watts, at the same time that we consider current, because there's no other way to consider current except in terms of watts. But voltage we can have all by itself along the length of the wire. And that's it, all by itself, one factor, voltage, that's it, all by itself. But when we want to consider current, we have to consider reactive voltage. The voltage of reactive power, or electrical reactance, I should say, because there's no such thing as reactive power, but electrical reactance, the voltage of electrical reactance in combination with applied voltage and impedance, all three gives us current and watts. That is the correct way to look at Ohm's law. Now, I'm hopping around on subjects, so it's easy for me to lose track of what I was saying a second ago. Maybe I should re-listen to myself. Yeah, I think I better stop this recording and go back and listen to myself to pick up where I left off.